Today we shall study about solar cell in semiconductor electronics. A solar cell is basically a PN junction which generates EMF. When solar radiation falls on the PN junction, it works on the same principle, photovoltaic effect, as the photodiode, except that no external bias is applied and the junction area is kept much larger for solar radiation to be incident because we are intensified because we are interested in more power. A sample PN junction solar cell is shown in figure 1. A PSI wafer of about 300 micrometer is taken over which a thin layer minus 0.3 micrometer of an silicon is grown on one side by diffusion process. The other side of PSI is coated with a metal back contact on the top of an SI layer. Metal finger electrode or metallic grate is deposited. This acts as a front contact. The metallic grip occupies only a very small fraction of the cell area, smaller than 15%, so that light can be incident on the cell from the top. The generation of EMF by a solar cell when light falls on it is due to the following three basic processes. The first is generation, second is separation, and third is collection. Generation of EH appears due to light with H nu is greater than Eg, energy gap, close to the junction. Separation of electrons and holes due to the electric field of the depletion region. Electrons are swept to N side and holes to P side. Collection. The electrons reaching the N side are collected by the front contact and holes reaching P side are collected by the back contact. Thus, P side becomes positive and N side becomes negative, giving rise to photovoltaic. When an external load is connected as shown in figure 2, a photocurrent IL flows through the load. A typical IV characteristic of a solar cell is shown in figure 2b. Note that IV characteristic of solar cell is drawn in the fourth quadrant of the coordinate axis. This is because a solar cell does not draw current but supply the same to the load. Semiconductors with band gap close to 1.5 electron volt are ideal materials for solar fabrication. Solar cells are made with semiconductors like Si, Eg=1.1 electron volt, gallium arsenide Eg=1.43 electron volt, cadmium tellurium Eg=1.45 electron volt, CuS and Ca Eg=1.04 electron volt etc. The important criteria for the selection of a material for solar cell fabrication are: first, band gap. Band gap band gap 1.0 to 1.8 electron volt. High optical absorption, electrical conductivity, availability of the raw material, cost. Note that sunlight is not always required for a solar cell. Any light with photon energy greater than the band gap will do. Solar cells are used to power electronic devices in satellites and spaces, vehicles, also as power supply to some calculators. Production of low-cost photovoltaic cells for large-scale solar energy is a topic for research.